We basically live our entire lives online now. But have you ever stopped to think about the invisible architecture that's holding it all together? Well, today we're going to pull back the curtain and look at the incredible systems that make sure our digital world doesn't just, vanish.
I mean, really think about that for a second. Your photos, your work emails, all the services your business depends on, poof, gone in an instant. And look, this isn't just some crazy hypothetical. We've all seen major services go down, and that exact fear is what keeps some of the smartest people in tech up at night, building solutions just like the one we're going to talk about today.
Because here's the thing. The stakes of an outage are totally different depending on who you are. For you and me, maybe a personal account being down for a few hours is annoying, but will live. But for a business, an hour of downtime is a full-blown crisis. And for government services, we're talking minutes, maybe even seconds, before it becomes a critical national failure. So this really gets to the heart of the problem. Reliability is not a one-size-fits-all deal.
So how do you actually protect against the ultimate digital catastrophe? Well, you call in the elite first responders for your data. And this is where we get to meet the hero of our story today, the Mirror Protocol.
Its mission sounds pretty straightforward, but in reality, it's unbelievably complex. The whole idea is to make sure your data is being continuously copied across multiple, totally separate cloud providers. Why? The goal is to prevent any data loss and to enable a lightning-fast recovery if one of those providers has a complete meltdown. It's basically a safety net for your safety net.
And this is where the analogy of a network of hospitals really clicks. Think of it like this. Your live, active data is running in the main hospital, in this case, Google Cloud. But at the same time, you have an identical, ready-to-go mirror hospital in a totally different city. That's AWS, ready for an instant failover. Then you've got an urgent care center on standby with Azure for quick recoveries. And for the really long-term stuff, all the records are kept safe in a deep archive, like Glacier. It's an absolutely brilliant strategy of redundancy on a massive scale.
Okay, so in any real emergency, what's the first thing paramedics do? They perform triage, right? They figure out who needs the most urgent help. Well, the Mirror Protocol does the exact same thing, but it's doing it for your data.
I mean, the answer is obvious, right? Of course not. A photo you uploaded 5 years ago can probably wait a little bit to be restored, but a financial transaction that's happening right now, that cannot be lost, not for a second. And this really simple, intuitive idea is the absolute key to making this whole system work so efficiently.
And this table just lays it out perfectly. You've got 3 tiers. Tier 1 is life support. This is for active transactions, the supercritical stuff where zero data loss is the only option. Then you have Tier 2, which is like urgent care. Think user profiles. Important, but a few minutes of delay isn't the end of the world. And finally, Tier 3 is the archives. This is for backups, media files, things where we can afford maybe up to an hour to get them back. And when we say Tier 1 is life support, we are not kidding. The replication, the copying of that data, happens in under 100 milliseconds. That is literally faster than the blink of an eye. It's this constant, real-time heartbeat syncing your most critical data to a safe location second by second.
Okay, so the system is ready. The copies are perfect. But what happens when disaster actually strikes? Well, that's when the system has to execute a failover. That critical split-second switch from a failing hospital to a healthy one, all without missing a single beat.
For the really bad, unexpected outages, the failover is completely automatic. It's like a system reflex. The moment a failure is detected, the system instantly verifies the mirror is healthy, it updates the DNS, which is kind of like the internet's address book, to point everyone to the new location, and then it switches all the traffic over. It's like a defibrillator for the cloud. It just works, instantly, before a human even gets the alert. But sometimes you need a planned procedure, like for a major system upgrade. That's when you do a manual failover. This isn't a chaotic reflex. It's more like a carefully orchestrated surgery. Engineers will meticulously verify everything's ready. They'll pause any new data from being written, ensure one final perfect sync, and then they make the switch with absolute precision.
So how in the world do you practice for a digital apocalypse with a command that looks just like this? And that little phrase at the end, -dry run, that might be one of the most important parts of the entire system. It lets engineers run a full-blown simulation of a catastrophic failure. It's basically a fire drill for the internet, so they can find any weaknesses without risking a single byte of live data.
This all sounds incredible, right? But it begs the question, how do we know it's always ready? How can we actually trust that the mirror is a perfect copy at all times? Well, that all comes down to constant, unending vigilance.
The system never just assumes it's healthy. You have to think of it as being in a state of perpetual self-diagnosis. It's constantly checking its own vital signs, making absolutely sure that the primary and the mirror are in perfect lockstep sync.
And these checks are incredibly thorough. We're not just talking about a simple ping to see if it's online. No, the system is constantly verifying the exact number of rows in every database. It's comparing data checksums, which are kind of like digital fingerprints, to detect even the tiniest bit of corruption. It's monitoring for timestamp drift and sending out alerts if the replication lag gets even a few seconds too slow. It's this multi-layered defense to guarantee the mirror is a perfect copy.
I absolutely love this analogy because it just perfectly captures the mind-boggling scale of what's happening here. This isn't a random spot check. This is a meticulous, constant, and totally automated process, making sure that two separate, continent-spanning libraries of data are identical, right down to the last byte. So the next time you open an app or use a service online and it just works, take a second to remember the incredible, invisible architecture that's running underneath it all. That effortless experience we all have, it's not an accident. It's the result of constant, mirrored vigilance. And it really makes you wonder, doesn't it? What other parts of our digital lives are we just taking for granted?